We're going to go over some parts of the atom, let's say. That includes atomic number, the number of protons, number of electrons, number of neutrons, the charge, etc. But for you to really know how to do this well, you really need to know about this part of the reading that I've assigned. Okay, these are the very important parts that you really need to know. Okay, so you need to know the protons, their charge is positive. Neutrons, they have no charge. And electrons, they have a negative charge. We also need to know the atomic number. The atomic number is pretty much the same thing as the number of protons in an atom, right? Atomic number is the same as the number of protons. And lastly, we need to know the mass number is number of protons plus neutrons. If you're wondering why does that not include electrons, it's because the mass of an electron is so tiny that it's not included in the mass of an atom, basically. It's very tiny. So mass number is only protons plus neutrons, right? There's one last thing actually. This thing right here. This is actually how you can notate the features of an atom, basically, knowing everything about an atom. This is called a nuclear symbol, okay? Nuclear symbol. And the nuclear symbol has several parts, as you can see from this arrow right here. The big Ne right here, that's the symbol for neon. That's called a chemical symbol. We have the number on top. The number on top, that 22, that's the mass number of neon, how many protons and neutrons it has. And then we have the number that's on the bottom. The bottom number is the atomic number, is 10 right here. Neon always has an atomic number of 10. Any element that has, or any atom rather, that has 10 for the atomic number will be neon, okay? Because atomic number tells you the identity of the element. Lastly, we have to also remember that the periodic table is useful for knowing the names of the elements. You can use a periodic table to complete the information about atoms and ions below. And you can use ptable.com, which is pretty cool. But realistically, you can use any periodic table you would like. Okay, ptable is just one that I found to be a pretty cool table. Very interactive. You can go from left to right. You can find out all the element names, and on the left hand side you got pretty much all of the information about the element. It's pretty cool in that sense. Just know that the periodic table, it tells you the names of the elements, and it's actually arranged by their atomic number from 1 all the way to 118, right? 1 all the way to 118. So it's very useful to knowing about the parts of an atom. Alright, so let's do this example right here. For this example, you can just listen and try to see whether you're following along, whether you can follow along. If you can, then you should be able to do the example, the class practice on the bottom. Okay, so just listen and hear me out for these first few atoms. Okay, I'm gonna go ahead and do this one right here first, the carbon 12 atom. Okay, well, this is the element name with the mass number. Okay, so we've got the element name, carbon, with the mass number 12. Next is nuclear symbol. Nuclear symbol has the chemical symbol, mass number on top, atomic number on the bottom. Okay, next column, we're missing the atomic number, right? But carbon has an atomic number of 6. You can tell that from the bottom of the nuclear symbol. Also, carbon is always 6. So if you look at the periodic table, search for carbon, you're going to find the atomic number is 6. Mass number is 12. It makes sense because of these parts right here. Those are also mass numbers. We're looking for the number of protons. Now remember, protons is the same thing as the atomic number. Proton is the same thing as the atomic number. Now we're looking for the number of electrons. Oh, sorry, the number of neutrons, my mistake. We're looking for the number of neutrons. And here the thing is, I know that protons plus neutrons is the mass number, meaning 6 plus something equals 12. That something has to be 6. Okay, 6 plus 6 is 12. Again, proton plus neutron is mass number. What about the number of electrons? This one's a little bit tricky one, but okay, let's think about this. Electrons. I know that electrons are negative. Okay, you should know that too. Protons are positive. Okay, protons are positive. Okay. Well, why do we need to know that? It's because we know the net charge here. The net charge is -4. So the overall charge of the atom is -4. Does that mean I should have more protons or more electrons if the overall net charge is -4? If it's negative, then there should be more electrons, right? Electrons are negative. And specifically, there should be 4 more electrons than there are protons. There should be 4 more electrons than there are protons. If there are 6 protons, and I know that there should be 4 more electrons than there are protons, then there should be 10 electrons, right? There should be more electrons than there are protons for us to have a negative net charge. Okay, hopefully you kind of got that. This is probably the trickiest one. Okay, is this an atom or an ion? Well, from our activity, from looking at the data from last time, we should know that ions have a charge. Ions are, by definition, a charged atom, okay? So, since we do have a -4 charge, this is an ion. If you're wondering, oh, what if it's a positive charge? That's a great question. A positive net charge is also an ion, okay? The only time it's an atom is if there is no charge, if there is 0 charge. Alright, let's take a look at the second one. I'm going to do this in a different color, green. In the second one, okay, what is the element name? Well, I don't know right now, but I do know the symbol is O, so maybe you know what element this is. But in case if you still don't, we can look at the bottom part of the nuclear symbol. That's the atomic number of 8. Okay, that's the atomic number of 8. I'm going to write this next one down just because it's right there. Mass number is 17. Okay, mass number is on the top of the nuclear symbol. But if we look at the atomic number, or if we look for O on the periodic table, we can find out the element name. Okay, so atomic number 8, or we're looking for O. If you look for it on the periodic table, it's on the right side. So 8 is always O, which is oxygen. Okay, 8 is O, which is oxygen. Oxygen. Okay, I'm going to write the mass number next to it, so it's going to be 17, right? Oxygen 17. Alright, now we're missing the number of protons. This is always simple, because protons is always the same as the atomic number. If you don't have one of them, you can get it easily by knowing the other. Atomic number and protons are always the same. Okay, now we know the number of neutrons, and we know the number of electrons, right? You can check to see if things make sense. So neutron, does it make sense if it's 9? Well, I know that protons and neutrons added together should give me mass number. Okay, so that means 8 plus 9 should give me 17. And that's correct. That is right, so that's good. The number of electrons is 10, but we don't know the net charge. But anything dealing with charge or electrons, you want to think about like how many positives and how many negative particles there are. Okay, so we have 8 protons, meaning we have 8 positive charges. We have 10 electrons, we have 10 negative charges. Which one do we have more of, positive or negative? Well, we have more negative this time, and we specifically have 2 more negatives than we have positives, right? We have 2 more negatives than we have positives. So the net charge would be -2. It's that simple. Alright, since we have a negative charge for this atom, this is considered an ion, right? It's an ion. Okay, let's do the third one now. Let's do it in a different color. I don't know the element name, I don't know the symbol, but I do know the atomic number is 15. Atomic number. If I know the atomic number, I can actually get the element, can't I? Because there's this thing called the periodic table, which organizes all of the elements. from the lowest atomic number to the highest atomic number. So we're looking for 15. We know the atomic number 15. So once you found it, you will know that it's P. Anytime you have an atomic number of 15, you have P, which is phosphorus. That's how you pronounce that. We have phosphorus here. Okay. We have atomic number and mass number, so we can fill this out. Okay, we can fill this out. Mass number is 31, and for the nuclear symbol, the atomic number goes on the bottom, the mass number goes on the top, right? So I'm gonna put those there. Alright, now what we're missing is number of protons. Easy, because I know the atomic number. Protons and atomic number are always the same. Number of protons is 15. Okay, number of neutrons. Oh, we can get that, because I know that protons plus neutrons equals mass number, meaning 15 plus something equals 31. What does that something have to be? Well, it's got to be 16, right? 16. Because 31 minus 15 equals 16. So you can check your work. 15 plus 16, does that equal 31? It should. Alright, next we have the electrons. That's good. We don't have the net charge though. But to get the net charge, you just consider the things that are positive and negative in your atom. So we're looking at the protons and the electrons. Which one do we have more of, positive or negative? We have more electrons, so that means we have more negative stuff. How many more? Well, 18 is 3 more than 15. So there's 3 more negative things than there are positive things. There's 3 more negative things. So net charge should be -3. And since we do have a net charge here, it's an ion again. Alright, let's take a look at the next one. Let's pick a different color. How about we go with purple? Okay, don't know the element, don't know the symbol, but I do know the atomic number. Anytime you know the atomic number, you can look at the periodic table to figure out the element. We're looking for 18. 18 is on the right side. If you're wondering, how do I find it so fast? It's organized by atomic number. It's going from 1 all the way to 118. So we're looking for 18. 18 is always AR, which means argon. Atomic number 18 is always AR, which stands for argon. So we got argon here, which is AR. We don't know the mass number, so I can't get this number down right now. So let's figure it out. What is the mass number? Well, the mass number is protons plus neutrons. But we don't know what protons is, right? Don't worry, because protons is always the same as something else. Do you remember? Proton is always the same as atomic number, right? So there's 18 protons here. Okay, now we can get the mass number, because number of protons plus number of neutrons is mass number. That means 18 plus 20 is 38, right? That's the mass number. 38. So I can write this number right next to the element name now. Argon 38 is this atom. Remember, nuclear symbol, the atomic number goes on the bottom, the mass number goes on the top, right? So here we go. That's the nuclear symbol. We are now missing, let's see, the number of electrons. Electrons have to do with charge, and electrons have a negative charge. Protons have a positive charge. So we know our net charge here. Our net charge is 0. So how do we compare the number of protons and electrons? Well, we know that if the net charge is 0, there has to be the same amount of positives and negatives, right? That's what we should be thinking. If the net charge is 0, there should be the same number of protons as electrons. So if we have 18 protons, there must be 18 electrons. Okay, 18 positive things, 18 negative things, they'll cancel out and give us a net charge of 0. And if it has no charge, this is an atom. An atom is something that has no charge to it. An ion is an atom with a charge. Okay, there's one last example. Hopefully you're getting this idea here. Hopefully you're seeing that, oh wait, this is actually pretty easy. It's a little neat little puzzle. Okay, element name, I don't got it. Element symbol, I don't got it. Atomic number, I don't got it. What the heck, how do I figure this out then? Whoa, look. I have the number of protons this time. And protons is always the same as atomic number, isn't it? So, the atomic number is 11. Okay, cool. Now that I know the atomic number, I can figure out the element, can't I? What element has an atomic number of 11? Let's look at our periodic table. What element has an atomic number of 11? There it is on the left-hand side of the periodic table. An atomic number of 11 means the element is Na, which is sodium. Okay, sodium. All atoms that have an atomic number of 11 are sodium atoms. Alright, we do have the mass number, excellent, so I can write down this is sodium 23. On the nuclear symbol, I can write down on the bottom the atomic number and on the top the mass number, right? So on the bottom we're going to get 11, on the top we're going to get 23. Excellent. We are missing the number of neutrons, but hopefully you know that protons plus neutrons will give us mass number. So 11 plus something is equal to 23. What must that be? 11 plus... it has to be 12. It has to be 12, right? 11 plus 12 equals 23. Okay, cool. We know the number of electrons this time, but we don't know the net charge. Anytime you're thinking about the net charge, think about the particles that have a charge in the atom. That's the proton and that's the electrons, right? So we have 11 protons, we have 10 electrons. So should the charge be positive or negative? Well, we've got more positive charge, so the net charge should be positive. Positive what? Well, there is one more proton than there is an electron, so only positive 1, right? Okay, net charge is positive 1. Now, that means that this must be an ion, right? Oh, cool. Okay, so colorful. Alright, so hopefully you found this kind of neat. This is like a little puzzle that we're doing, finding about the features of an atom. But really, all you need to know is this stuff right here. So if you didn't remember this stuff, like the atomic number and the mass number and the fact that protons are positive and electrons are negative, take a good like 20 seconds to try to commit that to your memory. You really need to know that. This is the fundamental of chemistry. Okay, fundamentals. Take like 20 seconds to remember that. After that, I want you to try this additional practice. Okay, try this additional practice. And then what I'm going to do is I'm going to go ahead and fill it out and speed it up. You can pause the video right now after you have tried it on your own, like maybe on a piece of scratch paper. Then you can unpause the video and see if you got it right. Okay. Okay, pause the video now. Alright, this is it. Hopefully you were able to get it. There's a little bit of practice, and hopefully you find it pretty easy and pretty fun actually.